Hello for everyone. Before starting my presentation, I would like to introduce myself. My name is Fadya Abbas, and I'm so happy to be here with you. Let's get started my presentation. My presentation is about an improved NLP for syntactic and semantic matching using bidirectional LSTM and attention mechanism. So, my presentation consists of many parts. The first part is going to be the introduction. In this part specifically, we are going to get an overview about NLP. What is it and what it's used for? Then we will see which kind of problems we are going to face while working on NLP. Next, we will see the solution I have used to solve the problems I used by LSTM and attention mechanism. Finally, we will see the result and the conclusion. So, what is the NLP? Well, NLP is family of artificial intelligence technique used to derive the meaning from the text data. NLP is mainly used for interactions between computers and human languages. In particular, how to process and analyze large amounts of natural language data. Let's see the difference between syntactic analysis and semantic analysis. Syntactic analysis is the process of analyzing natural language with the rules of formal grammar. So, it is the set of rules need to be ensured the sentence is grammatically correct, and most NLP technique can analyze that. While semantic analysis is the technique that attempts to understand the meaning of language. So it's something hidden in the data and cannot be computed directly. So NLP needs more time and effort to do that. What NLP can be used for? One, for machine translation. As we know, translation language cannot be done word by word. In the beginning, we have to understand the meaning of the sentence and then can translate it to another language. And this is exactly what NLP offers. It has the ability to understand the context of the text and then translate it to another language. To visual assistance, NLP is used to take human interests and derive the command to execute based on that. 3, semantic analysis and prediction. NLP takes some text and tries to understand the context of the text. Then can predict overall the meaning of the text or even predict the next word in the text. The main problems we are going to face while working on NLP. 1, data efficiency. 2, training limitation. 3, data associated with noise. Untransferability of complex data. The main solution is by using attention mechanism. What is the attention mechanism is going to do is get the most correlated and most important data and ignore the others. Therefore, it can improve the training limitation problem and leverage the model into more efficient data. The model architecture. My model architecture consists mainly of 3 layers. The first layer is the encoder, the second layer is attention mechanism, and the final layer is the decoder. This figure shows you the main layers of my model, while the x-axis are the words of the input sentences, which are going to get inside the encoder. The final layer of the encoder will hand the information and the data to the decoder after processing in the attention layer. The EWM and W prime are the adjustable weight between the hidden layers. The decoder layer is going to maximize the likelihood of the context vector probability, and then can predict the final summary of the word presentation. Let's talk about the next layer, which is bidirectional LSTM. As I said, the x-axis are the sentences which are going to get inside the tokenization layer. The tokenization layer is going to break the sentences into the words and embed it into the numeric vector. Each word will have a unique numeric vector. We are going to call it the token. Bidirectional LSTM, the forward layer, predict the next token for the given previous tokens of the input sequence, while the backward LSTM predict the next token for the given previous tokens in the reverse direction of the input sequence. By including two layers of LSTM, one takes the information forward and the other will take the information backward, can offer better prediction because they can improve capturing the word context representation in a sentence. The attention mechanism. The encoder output and decoder input embedding are both fed to the attention layer to perform attention between them. The attention layer generates attention vectors that can determine the relevance of ith word in a sequence that concern other words. So the attention model can capture the word relation of the input tokens in a sequence. Also, it sets large weight on the important tokens to the words and less weight to the less important tokens. On the other hand, the input and the output will get inside the attention mechanism spontaneously. The attention mechanism will generate the attention filter or score matrix, which includes the most correlated data. As you can see in this figure, the diagonal one has the most important data, which are going to be considering by the LSTM layer. The result, as you can see from this table, the progress which has done by using attention mechanism. Without using attention mechanism, syntactic was 59, but after using the attention mechanism became 61, semantic was 54, while after using attention mechanism became 58. The total accuracy was 57 and then became 60. The proposed algorithm is applied to the training data, which is taken from the Moby-Dick book. The test procedure passes 25 words as test data to the NLP algorithm, and the algorithm predicts 26th word. The conclusion. The proposed NLP architecture is represented by combining two powerful deep learning models. The first one is by LSTM, and the second one is attention mechanism. It successfully trained the model on several terms and phrases. It improves the training limitation problem and leverages the model into more data efficient. In future work, the technique will be used to train the large of the world models. We done